Diffusion is movement of a fluid from an area of high concentration to an area of low concentration. Diffusivity is a measure of this capability of a substance or energy to be diffused or to allow something to pass by diffusion. Imagine all of these guys are water molecules. Wes is in the light blue and is trying to diffuse through the matrix of the other guys. At the cold temperature, you can notice that all of them are moving very slowly, and thus Wes takes a longer time to make it to the other side of the room. Now if we were to increase the temperature, we notice that all of them are moving at a much faster rate, and Wes makes it to the other side of the room much more quickly. This is the basis on which our experiment is based.
He couldn't smell the spoiled milk because it's cold out, so the smell is diffusing too slowly for him to smell it. So for this experiment, you need 4 bottles of equal volume, water, food dye. You need ice and a heat source like a stove or a hot plate, and then a pot to put the water in, and a thermometer to check the temperature when you're cooling down or heating up, and a cup to pour the water into the bottles.
Alright, to start this experiment, we create ice baths in order to cool the water bottles down to 5 to 15 degrees Celsius.
While the 2 water bottles are cooling in the ice bath, you can begin to heat up 2 other water bottles by first placing them in a pot or a beaker in on a hot plate. Allow the water to heat up to approximately 60 to 70 degrees Celsius. Once both water bottles are at the correct temperature range, you can then add the food dyes. We're dyeing one a yellow color, approximately 3 drops should do. And the other, we are dyeing blue, again 3 drops.
Here we create a vacuum by squeezing the bottle and allowing it to bind to the plastic divider. We then slowly flip the yellow bottle and place it on top of the blue bottle. Having done this for both bottles, we can carefully remove the plastic dividers from in between the bottles. Be careful not to spill. The hot water apparatus appears on your left and the cold water apparatus appears on your right. You can either hold them together as we have done here, or you can tape the 2 bottles together and observe the color change. After around 60 seconds, we can observe the faintest green color occurring in the hot bottles, while there is a relatively little difference in the color in the cold bottles. After 90 seconds, we can easily observe a green color in the hot bottle apparatus, and in the cold bottle apparatus, we can begin to observe streaks of green beginning to form within the bottle. After a total of 3 minutes and 12 seconds, we can observe there is a very faint green color formed in the cold water apparatus, while in the hot water apparatus, the colors on the top and the bottom are nearly identical, indicating that the dye is diffused completely.
So our experimental results show that as temperature increases, diffusivity also increases, and chemical engineers use this property all the time in real life. An example is silicon, which is used in a lot of electrical components. In order to make it more conductive, you need to diffuse other kinds of atoms into it, and that process is really, really slow at room temperature, and it wouldn't be able to get a lot of product doing it that way. So chemical engineers design the process at a high temperature so that it happens really quickly and you can get a lot of good silicon that way.